Good day, everyone. Welcome in Physical Science. Now, before we start our class, I will be having a pre-test direction. Choose the letter of the best answer each item and write it on a separate sheet of paper. Number one, the accepted theory about the origin of the universe, which accounts for its continuous expansion and probable existence of primordial atoms. A. Big Bang theory. B. Divine creation theory. C. Steady state theory. Letter D. Oscillating theory. The answer is letter A. Big Bang theory. Number two. The following are light elements except A. Helium. B. Hydrogen. C. Lithium. D. Iron. The answer is letter D. Iron. Number three. The term used to describe the process which form the elements in the universe is A. Generation. B. Genesis. C. Nucleosynthesis. D. Synthesis. The answer is letter C. Number four. Light elements such as hydrogen and helium are formed through the process of nucleosynthesis. A. Big Bang. B. Fusion. C. Stellar. D. Supernova. The answer is letter A. Big Bang. Number five. Which element is the lightest and at the same time the most abundant in the universe? A. Hydrogen. B. Helium. C. Lithium. D. Iron. The answer is letter A. Hydrogen. Number six. A reaction in which two or more nuclei combine to form heavier nuclei. A. Combustion. B. Nuclear fission. C. Nuclear fusion. D. Nuclear synthesis. The answer is letter C. Nuclear fusion. Number seven. What element is primarily formed when three atoms of helium are fused through the Trialpha process? A. Carbon. B. Hydrogen. C. Oxygen. D. Silicon. The answer is letter A. Carbon. Number 8. Which of the following elements does not belong to the group? A. Beryllium. B. Silicon. C. Iron. D. Oxygen. The answer is letter A. Beryllium. 9. The process in which elements are formed at the center of a star. A. Big Bang nucleosynthesis. B. Nuclear fusion. C. Stellar nucleosynthesis. And D. Supernova nucleosynthesis. The answer is letter C. Stellar nucleosynthesis. Number 10. Elements heavier than iron are formed through A. Big Bang nucleosynthesis. B. Nuclear fission. C. Stellar nucleosynthesis. Or D. Supernova nucleosynthesis. The answer is letter D. Supernova nucleosynthesis. 11. The element that is formed when carbon atom is combined with helium atom. A. Magnesium. B. Neon. C. Oxygen. D. Silicon. The answer is letter C. Oxygen. 12. Average stars have longer lifespan than massive stars. This is because blank. A. They have less fuel to burn. B. They have more fuel to burn. C. They have burned their fuel at faster rate. D. They burn their fuel at slower rate. The answer is letter B. They have more fuel to burn. 13. Our sun is in what phase of its life cycle? A. Main sequence star. B. Planetary nebula. C. Red giant. And D. White dwarf. Answer is letter A, main sequence star. 14. Which of the following contains only heavy elements? A. Carbon, lithium, neon. B. Carbon, silicon, magnesium. C. Carbon, beryllium, helium. D. Helium, carbon, hydrogen. That is letter B. Carbon, silicon, and magnesium. 15. In which stage do massive stars explode and release large amount of energy? A. Main sequence. B. Protostar. C. Supernova. D. White dwarf. The answer is letter C. Supernova. Today we're going to discuss with you stellar nucleosynthesis, rise of stars. Now our objectives for today's lessons are 1. Explain stellar nucleosynthesis. 2. Describe the different stages of life cycle of stars. 3. Cite the different heavy elements formed in each stages of star cycle. The world where we live today is just a small part of our universe. In your previous lessons, science lessons, you have learned different theories about the origin of the universe that led to the formation of galaxies, solar system, and other heavenly bodies. This lesson will focus on one of those wonderful things in our outer space, the stars. Although stars are millions of light years away from us, we can still see them twinkling in the night sky. Let's find out how they emit light and what keeps them shining for a long time. Scientists believe that the formation of the universe began through the explosion of the primordial atom, which happened approximately 13.7 billion years ago. The origin of the universe is described by Big Bang theory, which was introduced by Edwin Hubble in 1929. Hubble demonstrated that all celestial bodies in the universe move away from each other. Now, this is the history of the universe. So we have the age zero here, and this is the Big Bang, until we reach the recent years, 13.8 billion years. Right after Big Bang, protons and neutrons combine and form light elements, hydrogen and helium through the process of Big Bang nucleosynthesis. Other light elements such as lithium and beryllium were also formed during this process. So we have here, we have hydrogen, and that's symbol for letter P, that's proton. So it's hydrogen one proton. And we have deuterium, so we have one proton and one neutron. And of course, we have neutron. And here we have helium-3, we have two protons and one neutron. We have helium-4, we have two protons and two neutrons. And this is considered as the alpha particles. And with the tritium, we have two neutrons and one proton. Lithium-6, we have three proton and three neutron. And lithium-7, we have four neutron and three proton. Stellar nucleosynthesis, the word stellar means star, and the formation of elements in the center of the star is called stellar nucleosynthesis. Carl Sagan said that we are made of star stuff. What did he mean by that? If we know how some important heavy elements were formed, same as stars, that may be a clue. Now label the sequence of the star life cycle used in the hints clues found in the below on this diagram. But before that, we're going to discuss first a life cycle of a star. So we'll start from here, nebula, and after the nebula, so we'll be having here a protostar and the main sequence star, and we'll be having the average star and massive star. And first we have the average star. So here I'll be having a red giant, and after that a planetary nebula and white dwarf, and of course we have the black dwarf. And for the massive star, we have this red supergiant, And we have here the supernova, and we have the neutron star and a black hole. All right. So here, the star life cycle. So we have 1, 2, 3, and to 10. So we have the average star and the massive star. For the hint and clues, so average star, no, the star is an A number one. The star is unable to generate heat when it runs. So out of hydrogen in its core, leading to its contractions and expansion. It cools down and glows red. The helium fused into carbon. The star is now red giant. Now for the hint number two, for the average star, red giant star becomes exhausted of the nuclear fuel. So the outer material is blown off into space, leaving the inert carbon. The remnant is known as a white dwarf. Three, giant cloud of gas and dust known as nebula. Four, it is formed from nebula due to the gravity that pulled hydrogen gas together until it spins faster and faster and becomes ignited. Then a process arises. Five, main sequence star starts to form when nuclear fission occurs at the core of the stars. It begins to contract, glow, and become stable. Hydrogen is converted into helium. Six, this is said to be the remain of the white dwarf that cooled down and no longer emits light and heat. So the hypothetical is a black dwarf. Now for the hints for a massive star for number one is it is believed that a neutron star is formed from supernova explosion. So this is also the smallest star. Two, explosion of star or supernova releases large amount of energy. Because of that, elements are dispersed into the space. Three, black hole is a region in space where gravity is too strong that no matter can escape from it. Number four, more massive main sequence like star evolves, cools, and expands faster than low mass star, and will return it into the red supergiant star, the largest known star. So carbon fusion still occurs and oxygen was formed. All right, for number one, uh, the answer for number one is nebula. Number two, protostar. Number three, main sequence star. Number four, red supergiant. Number five, supernova. Number six, we have black hole. And number seven, we have Newton stars. Newton star. Number eight, we have red giant. Number nine, we have white dwarf. And number 10, black dwarf. So now what is a nuclear reactions? So it is a reaction that involves a change in the nuclear particles. And it talks about nuclear particles or it talks about protons and neutrons of an atom. Now we have two types of nuclear reactions. So we have radioactive decay and nuclear transmutation. So first, the radioactive decay. So it means that it occurs naturally, while nuclear transmutation, it's an artificial or it's being induced to form a reactions. Now here are the nuclear reaction radiations. So we have particular radiations and symbol. So we have first, we have proton. So the symbol for proton is P and one atomic number and one mass number. Or H means hydrogen, atomic number one and mass number one. We have neutron, so we have symbol for small letter n, and we have mass weight of one, and of course we have zero. Beta particle or electron, so we have here, we have E as 0 and negative 1, or the symbol like this, the beta, so 0 and negative 1. For the alpha particle, so we have here, symbol this, and we have 4 and 2, atomic number is 2, and mass weight is 4. Or we have helium or He, so we have 2 and 4. Another one particle is positron, so we have here 0 positive 1 E, or we have 0 positive 1 beta. Next was gamma ray photon. So we have 0, 0, and of course we have the element here. Or we have the 0, 0, and we have the 5. Below are the diagrams for us understand better how stars are formed into different stages because of nuclear fusion, or it's what's called combination of nuclei to form heavier one among heavy elements. So we have first the nuclear fusion, or this is also called the proton-proton chain. The proton-proton chain in a main sequence star. So in this process, the average star gets its energy and convert into hydrogen and helium. It starts with a proton and a neutron, which fuse together to form deuterium. When another proton collides with deuterium, then it will produce helium-3. Now, if helium-3 and helium-3 will collide from each other, it will produce helium-4. And this is what we call proton-proton chain reaction or a nuclear fusion. So another one is the case is different from massive stars, so 8 times the mass of our sun. So these stars undergo CNO, meaning carbon, nitrogen, oxygen cycle. So first, okay, we're going to use this following symbols. So this one is Y, and this symbol is gamma ray. And we have smaller V, and that like this one, the neutrino or the neutron, and we have the O here, is the positron. Now, let's start. So we have here, so CNO, or this is what we call carbon, nitrogen, oxygen cycle. We're going to convert hydrogen into helium. So here, let's start from carbon 12. When carbon 12 fused to proton in the form of hydrogen, then to the use of gamma ray photon energy, it will create nitrogen 13. If nitrogen 13 undergoes beta radiation or beta decay or radioactive decay, therefore it will form carbon 13. And carbon 13 will fuse to hydrogen or proton in the form of hydrogen in a gamma ray energy. So it will create nitrogen 14. If nitrogen 14 fuse to hydrogen or a proton, then it will form oxygen 15. When oxygen 15 undergoes beta decay, so it will produce nitrogen 15. If nitrogen 15 fuse to hydrogen or proton, so it will create carbon 12. And this is what we call carbon-nitrogen cycle. And then the process repeats again and again and again. The next one is the Trialpha process, happens in red giant star. Once they leave the stage of main sequence star, this is how 3 helium-4 are converted into carbon. So here, let's start from first alpha and the second alpha particle. So if you're going to fuse or collide these two nucleus, then it will form beryllium-8. If beryllium-8 will collides to helium-4, then it will create carbon-12. And of course, we have here the energy release through gamma ray. And this is what we call tri-alpha process. Helium-4 converted into carbon. Another one is the star accumulates more mass and continues to grow into red supergiant. So alpha particle fusion happens at its core, and creates more heavy elements until iron. So this is known as alpha ladder process. So we'll be having 11 alpha ladder process. So we have here, we'll start from carbon 12, right? So carbon 12 plus 4, we have oxygen, 16, then plus 4, we have neon, then magnesium, silicon, sulfur, argon, calcium, titanium, chromium, and we'll have iron. So iron is our last step, all right? So we're going to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. However, if we're going to continue that, then as for again, so we'll be having nickel. In this case, it will undergo beta decay process. So let's start from nickel, and the atomic number for nickel is 28. And then if undergoes beta in a negative form, so it will produce an atomic number of 27, and that is cobalt. So cobalt 27 and 56. Then, if you're going to continue through beta radiation or beta decay, so it will produce iron again. So start from 27, so that's negative 1, that would be 26. And of course, the atomic weight is 56, so it means that 0 for the electrons and negative 1. So we have 26, and it will end to iron again. And this is what we call alpha particle fusions and alpha ladder process. How do elements heavier than iron form? So as an energy at the core of the star decreases, nuclear fusion cannot produce elements higher than iron. A different pathway is needed for heavier elements to be formed. Neutron capture, or a neutron, is added to seed nucleus. Before it before is the representation of how nucleus is captured and heavier nucleus is formed. So for example, we have here the representation for mass weight and atomic number, and X stands for the element, plus we have neutron here, and 0 and past 1, atomic weight is 1 and mass number is 0. If we're going to fuse this, then it will create this one, and this is our product. This is our reactant, and this is our product. All right, so we're going to A plus 1, and of course, Z plus 0, so we have the Z, and of course, we have the Y here for the element. Like for example, we have iron 26 and 56, so 50 is atomic weight, and 26 is the mass number. Plus, we have 3 neutrons, so 1, 0, 56 plus 3, so 3 plus 1, that would be 59. And we have 26 plus 0, so 3 times 0 is 0, so 26. So what we're going to do is to look to the periodic table, the number 26, right? So the number 26, or the element that has atomic number of 26 is iron. So the product will produce if iron will fuse to 3 neutron. Again, it's iron. Neutron capture can be slow or rapid. So S process, or slow process, happens when there is a slow rate of capturing neutron, while there is a faster rate of radioactive decay, hence increasing the proton by 1. So for example, we have here neutron and we have iron. If neutron and iron will fuse together, and this is the process, then the result is 0 plus 26, that would be 0, 26, well, and 1 plus 56, that would be 57. So atomic number in the periodic table, that is 26, so it's iron. And if the iron will undergo radioactive decay through beta radiation or beta decay, so we have here, then it will produce cobalt 27 and 57. So we have 26, of course, minus negative 1, that would be 27, and 56 plus 0, that would be 57. Our process or rapid process means that there is faster rate of capturing neutrons before it undergoes radioactive decay. Thus, more neutrons can be combined in the nucleus. This is what happens in a supernova forming heavier elements than iron with the process known as supernova nucleosynthesis. For example, we have three neutrons here and we have one element and in the form of iron, 26 and 56. And this is the process. So if the three neutrons will fuse to this element, so we have 3 times 56, that would be 59, and 0 plus 26, that would be 26. And the periodic table, the element that has atomic number 26 is iron. Right? So in this case, we have one neutron and fused to this element, and it will become 26. All right. So here 26 and 59 plus 1, that would be 60. All right. And if iron undergoes again a beta radiation, so we have 26 minus negative 1, so that would be 27. And of course, we have 2 here, neutron, that would be 61. So we have 27 in cobalt 61. Now, for your activity, so match the terms in column A with its description in column B. So we have letter A and we have letter B. Now, for the answer for this activity, the number 1 is letter B. Number 2 is letter D. Number 3 is letter J. Number 4 is letter H. Number 5 is letter G. Number 6 is letter A. Number 7 is letter C. Number 8 is letter I. Number 9 is letter F. Number 10 is letter E. Another activity, so read the paragraph, then fill in the blanks with the correct words. It all starts with blank, cloud of gas, and dust particle in the outer space. Due to the force of gravity, the blank gas is pulled together and eventually became a protostar. Nebular fusion occurs at the center of the protostar and becomes stable. During this time, hydrogen is converted into three or blank, forming main sequence star. The size of the star can be average or massive. A massive main sequence star that runs out of hydrogen fuel will begin to expand and cool down. This is blank, the collective term for massive stars in the universe. The red supergiant continues to fuse with heavy elements and stops when blank is converted in the core of the star. At this point, red supergiant will become a supernova after hundreds of years. Now the answer for number 1 is nebula. Number 2, hydrogen. Number 3, helium. Number 4, red supergiant. And number 5, iron. Now you have learned how stars are formed. Go through their lifespan and how each stage of the life of a star leads to the formation of elements. These are many processes that stars have to undergo before they evolve from one stage to another. For your next task, you will write a story which relates the events of your life from past, present, and future to the life cycle of a star. Use also those elements which could symbolize something or anything in your story. Use another sheet of paper for this task. Now, this is the rubrics for story of your life. So I have a criteria, whether it's excellent and fair and poor. So overall effort, background context, grammar and spelling, and content. Now, for excellent, work shows time, effort, and neatness that enhance the overall written output. Now, your score will be fair if your work shows time and effort put into it. And for the poor, lacks effort and cleanliness. For the background context, so the student's output contains background and context and shows how world events have significantly affected his or her life. For the fair, project contains discussion of the world events, but it's unclear how they have affected students' life. For the poor point, no background or context at all. For grammar and spelling, the student does not commit error when it comes to grammar and spelling. So fair, the students commits 1 to 3 grammar mistakes and spelling. For poor, students commits more than 4 mistakes in grammar and spelling. For the content, students includes information about birth, friends, family, hobbies, and is able to be his or her story to the topic given. Your score will be fair if the students includes very few details. Output is somewhat tied up with the topic. And for no information included is not related to the task or no attempt was made. So this is the rubrics for story of your life. Now for the assessment, so choose the letter of the best answer and write the chosen letter on a separate sheet of paper. Number one, which of the following is not an evidence of star formation? A. Hydrogen. B. Helium. C. Infrared radiation. D. Rocks. For number two, star's energy is produced by which process? A. Combustion. B. Decomposition. C. Nuclear fission. D. Nuclear fusion. Number three, if the sun reaches the end of the red giant phase, it will evolve into blank. A. Black hole. B. Supernova. C. Red supergiant. D. White dwarf. Number four, a category which includes the largest stars in the universe. A. Main sequence star. B. Red giant. C. Red supergiant. D. White dwarf. 5. Which of the following elements are major components of star? A. Carbon and oxygen. B. Helium and carbon. C. Hydrogen and carbon. D. Hydrogen and helium. 6. Which of the following statement is false? A. The core of the red giant star is made up of carbon. B. The average star has shorter lifespan. C. The more massive the star is, the faster it burns its fuel. D. No element heavier than iron can be produced in a massive star. 7. Which is the first stage of a star's life cycle? A. Black hole. B. Nebula. C. Protostar. D. White dwarf. 8. In main sequence star, hydrogen atoms fuse to form helium. Helium is then converted into blank at its core. A. Carbon. B. Iron. C. Neon. D. Silicon. Number 9. This element is produced through Big Bang nucleosynthesis and it's considered as the second most abundant element in the universe. A. Carbon. B. Helium. C. Hydrogen. D. Oxygen. 10. What object is formed from gas and dust particles which are pulled together by gravity wherein no nuclear fusion has happened yet? A. Nebula. B. Main sequence star. C. Protostar. D. Red supergiant star. 11. Who stated that we are made of star stuff? A. Carl Sagan. B. Edwin Hubble. C. Galileo Galilei. D. Stephen Hawking. 12. What is the sign that a protostar will transform into the next stage. A, when it starts to spin faster. B, when it starts to glow. C, when hydrogen nuclear fusion begins. D, when it increases temperature, igniting the hydrogen. 13. When does a star become unstable? A, when it runs out of fuel. B, when it contracts and expands. C, when its core is converted to iron. D, when the outer shell of star is pulled by the gravity from the center. 14. Which elements fuse together to form iron? A. Carbon fusion. B. Neon fusion. C. Magnesium fusion. D. Silicon fusion. 15. This is a huge luminous ball of hot gas, such as hydrogen and helium. A. Comet. B. Moon. C. Planet. D. Star. Now, let's check your work. So the answer for number one is letter D. Number two is letter D. Number three is letter D. Number four is C. Number five is D. Number six is B. Number seven is B. Number eight is A. Number nine is B. Number 10 is C. Number 11 is A. Number 12 is C. Number 13 is A. Number 14 is D. And number 15, D. Now for your additional activities, on this activity, you will see a star with a topic written on its center. Fill out the parts of the stars with concepts that you have learned in this lesson. That's it for today, and thank you for listening. Goodbye.